For today's video, we'll be talking about the first part of a segment over z-scores. As you can tell, this is entry 32. Yours may be a little bit different, just kind of depends when we talk about it in the year. The standard we are talking about is MM3D3. Z-scores are used when a set of data does not have a mean of 0, which happens about 99% of the time. We're going to need to change it to z-scores. Now, z-scores let us compare all data on a level playing field. Doesn't matter where we surveyed it from, we can compare it all evenly. Now, a z-score itself means how far above or below the mean a piece of data is by using the standard deviation. So your mean is here. If we end up with a negative z-score, it ends up to the left of the mean, so it's over here somewhere. If it's a positive z-score, it ends up over here to the right of the mean. Now, when we're looking at a z-chart, it's going to tell us what percent of the data is below that score in the population. So if you think, if we have a negative z-score, if it's a negative z-score, we expect that percent to be very low because it's saying what is below the number. If it's a positive number, we expect it to be very high because if our number was right here, all of this data over here would be underneath it, and that would be a lot. So, moving on. How to use a z-chart, otherwise known as a standard normal cumulative probability table. A z-chart table is a lot easier to say. So, the way you read it is positives are on one side, negatives on the other. So, for example, here is a z-chart paper. So you can see this one is all negatives because it's all starting with negatives here. If we keep scrolling down, you will see eventually that we will see positives. Let me go the other way. There we go, positives. One sheet all of positives, one sheet of all of negatives. There is a lot of them. So going back to this. Now where the row and the column meet up is going to be the percent we're looking for. So for example 1, we have 2.14. We want to know what percent of our data is going to be below that. So 2.1 is going to be the row we're going to look at. And then 4 is going to be the column we're going to look at. So let's take a look. We need 2.1, which is right here. Now we got to match that up with the column that had a 4 at the top. So we got to figure out which column that is. So it's the 1, 2, 3, 4, this column right here, the fifth one over. So we need to find the 2.1 row and move 5 over. 1, 2, 3, 4, 5. So 0.9838. So essentially 98.38% of the data lies below that piece. Let's do the same thing for the other example. Negative 1.57. So negative 1.5 is going to be our row. 7 is going to be our column. So let's go through to our z-score table. We need this negative page. We need negative 1.5. It's right here. We need to know which column to look at. So we need the one that has a 7 at the top. And 7 is right here. So we need the third column over. So negative 1.5 and match it up with the 7. So this right here. So if we move the decimal place 2 times, 1, 2, we end up with 5.82% of our data is below this particular piece. So not very much. Continuing on, the next thing we need to do is we have to be able to convert data into a z-score so we can compare it using that table. And to do that, we need this formula. And you see these 4 symbols, z, x, the mu, then our standard deviation. Z is going to be your z-score. That's what we're going to use to look at our table. X is going to be your piece of data. They may just tell you it's a piece of data, or I may try and tell you it in a kind of funky way. We'll get to that when we get there. Right here, that's going to be our mean, and then on the bottom is our standard deviation. So, using that formula, let's take a look at the 2 examples. Take a minute, try them on your own. Okay, so let's go through. Get my pen. So we have our piece of data, which in this case is our 10. Subtract our mean from that, which is our 7, and divide by 2. So if you think 10 minus 7, that's 3. 3 divided by 2 is 1.5. So 1.5, but if you think we got to have another digit. If you don't have anything there, always add a 0. So 1.50 would be our z-score. 1.5 would be our row, 0 would be our column. So let's go through and do the same thing for example 4. We have our piece of data, that's our 5. We have our mean, that's our 10. So 5 minus 10, and we divide by the standard deviation, which in this case is 4. So 5 minus 10, we know that. That's pretty easy. That's negative 5. Negative 5 divided by our 4, that should be negative 1.25. So negative 1.2 would be our row, 5 would be our column, and we would match it up to see the percent.